Night in New York. Sirens stitch the air. A cop just cuffed one of the city's most wanted dealers. Headlines will tell the chase. We'll tell the physics. In the officer's hand, a service pistol. Energy. Engineered. This isn't about glory. It's about how a bullet moves. Precisely. How a squeeze becomes flame, pressure, motion. Inside the gun, chemistry wakes. Powder becomes gas. Gas becomes push. Push channels down steel, toward purpose. Speed is born in an instant. And with it, responsibility. Every action here has a cost. Ready? Step inside the mechanism. Chapter 2 begins as the trigger starts to move. Below, protected by a guard, the trigger. A simple lever, the human interface for a chain reaction of incredible speed and power. Inside, hidden, a single cartridge. A brass cup, neat container for a chemical drama. At its base, the primer, the spark plug. The case is mostly filled with smokeless powder, granular propellant, not an explosive. Nestled in the mouth, the bullet, inert for now, destined for a brief, energetic journey. Every part is still, waiting. The world seems to hold its breath. The stillness is deceptive, a delicate balance of forces. All the energy is locked in the tiny grains of powder. A state of high potential, like a rock teetering on a cliff edge. Or a stretched rubber band. The system is in equilibrium, a state of rest. But equilibrium is fragile. A small push, a deliberate action, will convert that potential into chaotic kinetic reality. The moment before is just that, a moment, and it's about to end. What happens when a finger tightens? The journey begins with that simple lever, the trigger. As it moves backward, it sets off a chain of mechanical events. Deep inside the frame, it releases a spring-loaded hammer, or a striker. The cocked component, held under tension, snaps forward with incredible speed. Its destination? The firing pin. A hardened steel rod designed to do one thing: transfer energy to a single precise point. The firing pin darts through a tiny hole. Its tip strikes the soft metal of the primer with a sharp, percussive blow. This is the first domino. That blow crushes the shock-sensitive compound inside the primer. A tiny, intense spark flashes through a hole into the brass casing. There, the propellant, smokeless powder, has been waiting. The spark doesn't make the powder explode. It makes it combust, to burn. It burns with astonishing speed, deflagration. In milliseconds, powder grains become a massive volume of extremely hot, high-pressure gas. The brass casing, once a container, becomes a pressure vessel, a tiny combustion chamber. Pressure skyrockets to thousands of psi. The expanding gas needs to go somewhere. It pushes in all directions. It pushes back against the cartridge base. It pushes forward against the bullet base. The casing is designed to fail, if anywhere, forward. The bullet, press-fit in the case mouth, faces an immense force. It's the only part built to move. So it does. It begins its journey, accelerating from zero with brutal, calculated swiftness. The bullet is forced out of the casing and into the barrel. The barrel is not a smooth tube. It contains helical grooves. Rifling. As the bullet goes down this narrow passage, the rifling bites the softer jacket and forces it to spin. That spin imparts gyroscopic stability. Like a quarterback throwing a perfect spiral, it keeps the bullet flying point first, resisting tumble. That stability is crucial for accuracy. The bullet's trip down the barrel lasts just a millisecond, but in that instant, a tremendous amount of physics happens. Expanding gas acts like a piston, accelerating the bullet down the barrel. And then, it emerges. In what we perceive as a single bang, a whole sequence of events unfolds. The barrel uncorks, and superheated, high-pressure gas is released. That violent expansion creates a shockwave we hear as the crack of the gunshot. At the same time, hot gases ignite on contact with oxygen, producing a brilliant muzzle flash. Slow it way down. The spinning bullet emerges first, followed by a roiling cloud of incandescent gas. This violent exit also creates backward thrust on the gun, like a tiny rocket. That push is part of recoil. The sound, the flash, the kick. They're all sensory artifacts of the sudden liberation of chemical energy. Follow the channel for more such interesting videos about daily science and fascinating things. So, we are back on the roof. The echo of the shot has faded, leaving only the city's hum. A thin tendril of smoke dissipates into the cold night air. The tense quiet has been replaced by a different kind of quiet. The small, heavy object is still warm to the touch. In a fraction of a second, it has converted a pinch of chemical dust into sound, light, heat, and most importantly, motion. It has transformed potential energy into kinetic energy with brutal efficiency, all according to a few fundamental laws of the universe. The entire process, from the trigger pull to the bullet's flight, is a story of energy transfer. Chemical energy becomes thermal energy, which becomes mechanical energy. That energy is partitioned between the forward-moving bullet and the backward-moving gun. The rifling even siphons off a tiny fraction of that energy to create rotational energy, giving the bullet its stabilizing spin. It is a cascade of conversions, a waterfall of physics, all happening faster than the blink of an eye. The gun itself is nothing more than a machine designed to manage this energy conversion in a controlled, repeatable way. But, understanding the science, the pressures, the forces, the velocities, also brings us to a clear and unavoidable conclusion. The physics are elegant, but their application has weight. The kinetic energy that sends a bullet flying is the same energy that allows it to transfer a devastating amount of force upon impact. It doesn't distinguish between a paper target and a living being. This power, born from simple principles, demands a proportional amount of respect. Every part of that explosive moment is governed by rules. Simple, elegant, and inescapable rules of physics. The most famous of these come from Sir Isaac Newton. His second law of motion, F or mi. The expanding gas pushes on the bullet's mass, causing rapid acceleration. A small light bullet can carry huge destructive power. Its incredible speed, velocity, is the key ingredient. A small mass accelerated to very high velocity is the point of a firearm. Newton's third law: for every action, there is an equal and opposite reaction. That's recoil, the kick against your hand. The force pushes the bullet forward and pushes backward against the cartridge, the slide, and the frame of the gun. The bullet goes one way. The gun tries to go the other. Conservation of momentum. Total momentum stays constant. Before the trigger pull, the system's momentum is zero. After the shot, the bullet has large forward momentum, small mass times very high velocity. The gun must have equal and opposite backward momentum. Because the gun's mass is larger, its backward velocity is much slower. The push is undeniable. Semi-auto uses that backward force to cycle the action, ejecting the spent casing, loading the next round. The dance of forces also involves kinetic energy. Kinetic energy, non-12 mv squared. Notice velocity is squared, v squared. Doubling speed quadruples kinetic energy. That's why muzzle velocity matters. Chemical energy in gunpowder converts into bullet kinetic energy, with some loss to heat and some loss to sound. That kinetic energy does the work at the other end, punching a hole in a paper target or causing something far more serious. So, the one clear idea that remains, hanging in the air long after the smoke has cleared, is about the responsibility that comes with harnessing such power. A firearm is a tool for applying the laws of motion in a very specific and dramatic way. To understand how it works, to see the simple, beautiful physics hidden within the flash and the kick, is to also understand the magnitude of what it can do. The science is fascinating, but it ultimately serves as a profound reminder. The energy we unleash is our responsibility to control. And safety is not just a rule. It is the practical application of that understanding. The physics are elegant, the mechanisms precise, and the moment is brief, but the responsibility endures. Follow the channel for more such interesting videos about daily science and fascinating things.